Hello friends, welcome to Programming Tips. So far we have completed conditional operators, conditional statements and switch cases. So today we are going to start loops in C program. So basically when a block of code execute repeatedly, that means execute continuously until a condition is met, is called loop. So in simple word you can say when your program is able to run a lines of code continuously until a condition is satisfied, this thing is called loop. So basically we can divide the loop in two parts. One is entry control loop, entry control loops. Another one is exit control loops. Okay, so in entry control loop there are two types. One is for and another one is while. For and while. And in exit control loops, so one type of exit control loops are here. So this is called do while. So in for, if I write the syntax of for, it will be like this way. So for, then initialization, then test expression, then you can say update the statement. Initialization, update the statement. Okay, so here will be the body of loop, body of for. Okay, so initialization, test expression, then update. So three things is important in this for loop. After it will enter into the body of for. Okay, so in entry control loop, test expression or test condition is checked before entering into the body of loop. Okay, so this is called entry control loop. Same way in while also, in for also. Okay, so if I draw a flow chart, if I start the program here, then it will be initialization, then test expression. So test expression will be diamond shape box. Test expression, then if it is true, it will enter into the body of loop. Okay, that means body of for. Okay, so after body of for, it will update the statement. Okay, update the statement, whatever you initialize here, that part will be update here. Okay, update the statement, then it will again comes here. Okay, so if the test expression is true, whatever condition you set here, if the condition is true, then it will enter into the body of loop, then again it will update the statement, then it will come here. So it will continuously rotate here until the condition is false. If the condition is false, it will exit, it will exit from the loop. Okay, exit means it will print whatever outside of the loop. You can say the exit from loop. Okay, so whatever outside of the loop, it will print that thing. Okay, then stop. Okay, so here initialization first, then test expression. If the test expression is true, then it will comes to the body of the loop, then it will update the statement. So here how it will update the statement. So update the statement means it can update the statement through increment or decrement operator. Let me just erase this part. We'll describe this thing later on also. So this is entry control loop, right? So how it will update the statement. So here update part, how it comes update by using increment or decrement operator. Okay, increment or decrement operator. Increment through what? Plus. This is increment, and decrement means minus. So there are two types of increment operators there. One is post increment. Post means, suppose if I take a variable I, that means I plus. Yeah, then another one is pre increment, that means plus of I. Okay, fine. So in this way it will increment or decrement. So here I plus means I equals to I plus 1. Okay, so that means it will increment the value by 1. It will always increment the value by 1. If I take I equals to 1, then after I plus plus, it will become 2. Okay, so when we write the program for increment and decrement, that time we can easily understand. So let me try a program where we can understand how it's increment or decrement the value. So let me take a variable int I. Okay, let me increase the size. I equals to, suppose you can say 2. Okay, so here we'll try printf. You can say example of post increment, right? First one is post increment. Okay, post increment. So here you can write percentage d, then you'll write I plus plus. Okay, so I am writing post increment here. Then again I am writing here, let me just copy this line. Okay, so example of not here post is pre increment percentage d plus plus of I. Okay, I will remove this plus this 2 plus. Okay, so here example of this post increment, right? So here when I run this program, so what will be the output of this line? This line output will be 5. So how it's 5? As I already told you, I plus plus means I plus 1, that means according to the condition it can it will be 6, right? But it's I already called, it is called post increment operator. Post increment, that means it will increment the value after its printing. So why after printing? You can see here will be 5 and here will be, I will show this result later on. Okay, so here what is going to print is going to print, oh okay, sorry, I take I equals to 2, so it will print 2. Fine. Sorry, so it will print 2. But when we access this value here, it will become 3. How? See, as we already know, percentage d always searching for an integer variable, so it will search it here. After this comma, it will search it here. Okay, so that means if I end this double quotation, that means this is the end of this statement. Okay, so after this end of this statement, after this comma, it will search for an integer data type, right? Integer variable. Okay, so when it find that I variable, at that time it will print that variable. Okay, so I value is 2. Okay, it will instantly print that variable. But after printing, something is missing there. The line is not end here. Okay, so here plus plus is there, so it will be 2 plus plus. Okay, it will be 2 plus plus, that means it will become 3. Okay, after printing it will become 3. Before that means it will print the I value 2 here. Okay, but after printing it will become 3. So if I access this variable here, suppose if I want to write if we want to print the value of I here, percentage d comma. Okay, if I want to access this value here, you can see the value of I will become 3. See here. Okay, I is 3. Okay, after printing it increment the value of I. I just put a slash in here. Okay, so here when is going to search a integer variable, that time before printing the value of I, it will do its operation. That means it will plus the I by 1. Okay, so it's become 3 here. Now it will be 4 here, right? See here 3, then example of pre-increment operator is 4. So in this way pre-increment and post-increment works. Okay, clear? So pre-increment and post-increment work in like this way. Okay, let me just erase this part. Okay, so pre-increment and post-increment, and fine. So now come to the for part. So how we will write the syntax of for? Okay, so if I write for, then initialization, I'm not writing in full, initialization, then test expression. This is test exp, text expression, then update. After update, then we'll write the body of loop. So if I write an example here, suppose I want to print hello world 5 or 6 times. Okay, then how we'll do this thing? Okay, let me do it here. So if I take, okay, we'll take I here, then I'll write the loop for I equals to 0. Okay, I am initializing the value I as 0. Okay, I set the test expression, how many times it's going to print that hello world. Okay, so I am writing, suppose I want to print 5 times, so I need to write what? I less than 5, because we are starting the I value from 0. Okay, fine. So I less than 5, I plus plus. Fine. From 0 to 5, that means 0 to 4, because it's less than 5. 0 to 4, that means 5 times. So we'll write here printf hello. Okay, so that means hello world will print 5 times from 0 to 4. Okay, it will print the hello world 5 times. Okay, I didn't put slash n here. I am putting a slash n, simply a slash n. So it will come in new line. Okay, hello world 5 times is printing the hello world. Clear? Okay, now next question is, so how I can print all the numbers in that range 0 to 5. So here in this loop, which value is continuously incrementing? Okay, only I value, right? So only I value is continuously incrementing after each and every test expression. Okay, so instead of writing hello world, if I write here percentage d, okay, slash n comma I, if I simply print the value of I, or print the I variable, you can say, is printing all the numbers up to this limit, I less than 5, that means 4. So 0 to 4, it will print the values. 0 to 4, it will print the values. So if I want to set this thing, that means if I want to set this limit as user defined, how we can say? So we will declare another variable here. Okay, n. Okay, I will take the value from user, printf enter limit. Okay, scanf percentage d and percent of n. Okay, up to user defined times we will print that number. Okay, enter limit. Okay, now what we'll do here, we'll write less than equals to n. Okay, it will start from 0 to less than and equals to n, that means up to that time it's going to print. So if I just run this program, enter limit is asking that limit here. Okay, if I write here 12, press enter, it will print from initial value to limit times. Okay, whatever you set the limit, if I just put here 12, so 12 from 0 to 12, it printing all the values. Fine. So again, if user want to set the lower limit, we want to print the value from suppose 12 to 15, 12 to 35. So that time what user have to do, suppose we are taking another variable m. Okay, we are also taking this value from user, enter suppose lower limit, you can say enter lower limit. Fine. So here I will put m. So from m to n, it will print the values. So whatever you will press, whatever you will type here, suppose I want to print from 89 to 109. Okay, see here. Okay, sorry, it start printing from 0. Okay, so what? Okay, sorry, I didn't set the lower limit here. Whatever user is giving, I didn't set that one. So again, I'll start the program. I will enter the lower limit from 89 to 125. Fine. See, it's printing all the value from 89 to 125. Fine. Simple program. Fine. Now we want to print the sum of all these natural numbers. Okay, in a given range. The question is sum of all natural numbers in a given range. So what we will do, we will do, suppose we are going to take a variable s. Okay, we will initialize the value as 0. Okay, so we are going to add s equals to s plus I. Okay, so I value is printing here, so that's why we just set s equals to s plus I. So if I print here printf sum equals to what percentage d, then what will happen? The sum will continuously print. This line will also continuously print. So what we have to do, see here, yeah, enter limit 25 to 36. See, sum 25 again is printing 51, 78. So it will continuously print that that statement. Okay, so what we have to do, we need to print this line here. So this thing you have to understand where you need to print this value. So it will do the operation continuously. After ending the loop, it will print the sum value. Okay, so let me just check 12 to 39. So continuously it will print the value 12 to 39. After that, it's this give the sum of this all number. Okay, next question, if I want to print all the even numbers, how will you print this? Here the value of I is printing all the even and odd numbers. If I just filter that number before printing, filter, that means if I just set a condition here, so only the even numbers is going to print. If I set the condition like I mod 2 equals to 0, if I set this condition here, then it will print only the even numbers. Fine, you can see here 25 to 98. See, only the even numbers 26, 28, 30 up to 98. But the sum will be the sum of all numbers, because I didn't put this thing inside the if condition. Okay, is taking all the I values, only this line only printing the even numbers, because see here, this is the body of if. So this line is taking all the numbers, not even numbers, all the numbers. So is taking the sum of all the numbers, but is only printing the even numbers. If we want to print all the even numbers, then you need to put it inside the if. So sum of even, fine, you can see 25 to 98. It will print only the sum of even numbers. Okay, 98 up to 98. Okay, so if you want the again odd number also, sum of all odd numbers, then nothing to do, just copy this line. Okay, sorry, you need to take another variable, suppose so sum of odd equals to 0. So same way you will write here so. Okay, and again sum of even, control C, control V, sum of odd, it will be so. Okay, slash n is there, no issue. From 25 to 68, see, only the even numbers is printing, and odd number doing sum of even numbers and sum of odd numbers. Okay, so if you want to print suppose, yeah, if you want to print all the numbers, because we are going to print we are going to print the sum of all even numbers and odd numbers. So 25 to 35 is printing all the numbers, but it's giving the even number sum and odd number sum separately. Now let me check the program list. So C program to print all the number. Okay, we already completed this thing. Then calculate the sum of all natural number. C program to print all the even numbers up to n, you can already completed. Odd number also print sum of all even and odd numbers. Okay, we already completed this 5 program. Now the 6th program is C program to find a factorial of a number. So how to find the factorial of a number? So what do you mean by a factorial of a number? I think all of you know, but still, if I take number 5, so what will be the factorial of this number? So we have to do 5 into 4 into 3 into 2 into 1. Okay, like this way you can write. Also you can write 1 into 2 into 3 into 4 into 5. Like this also we can write. Okay, so we can continuously take the numbers up to a certain limit, right? Okay, now we need to just do the multiplication. Instead of doing sum, we need to do the multiplication only. So okay, let me just write the program for you. So for no need to do all this thing, enter lower limit and upper limit. Simply you can write here fact into equals to I. Okay, same thing. This line also you can write in this way, fact equals to fact into I. Both of the meaning is same. Okay, so fact equals to fact into I. Now we'll print the factorial of this number. So we'll do a we will write a statement. Okay, factorial of percentage d. So here we'll take two variable equals to, we have taken m the number, then fsc effect. Okay, we'll put the semicolon here. Factorial is suppose we take 5. So you can see here 5 factorial is 120. Fine. So in this way we'll find the factorial of a given number. So next program, what is the next program? C program to generate multiplication table. So here how we'll do that, multiplication table in the sense of, suppose if you have taken 5, okay, so we want to take the multiplication table of 5 up to 10 or 12, whatever you want you can give. So this thing we will write this program such way it will display like this way: 5 into 1 equals to 5, 5 into 2 equals to 10, 5 into 3 equals to 15. In this way this program will display. Okay, so how will write this program? Let us just okay, fine, we want to, okay, so we'll just modify this program little bit. Suppose you have taken I and then n, okay, up to where you can also take, or no, yeah, this is your wish. Enter a number, percentage d, it will take in n. Okay, up to how many times? So if you want to take 10, you can take 10, or 15, you wish. Okay, so here in this one we want this statement repeatedly. Okay, in each and every loop we want to that means want that statement, right? So percentage d into percentage d equals to percentage d. Okay, so now here we will write. So for first percentage d, suppose we want to print this number in this way. We want to print this number in this way. So 5 into 1, 5 into 2, 5 into 3, 5, 10, 15. We want to in this way. Okay, we want this in this line. So here percentage d into percentage d. So first percentage d will be here is 5. That means whatever you are entering n. Okay, second percentage d will be this I. Okay, because I value is only continuously increasing one by one. So next one will be the result. Suppose what will be the result is n into I. Okay, n into I. Okay, so it will show the result here, n into I in a single line. Okay, so just now we are printing enter a number. So that means if I enter 7, so you can say, sorry, I forgot to put slash n. I'm putting one slash n. Now you can see here, suppose I am taking 8, 8 1 8, 8 2 16, 8 3 24. Like this way it is print up to 10 times. Okay, you can increase the limit also, or you can take the limit from user also. Okay, so this is up to you how you will decorate the program. Okay, up to 15 times is repeating. Okay, so this is multiplication table. Now the program is next program is Fibonacci sequence. So what is a Fibonacci sequence? So now this is a little bit a tricky problem. So what is a Fibonacci sequence? Fibonacci sequence are suppose is always start from 0 and 1. Okay, these two numbers are constants. It's always start from 0 and 1, and the next number will be the sum of these two number, 1 plus 0. So that means again 1. Okay, and then next number will be the sum of last two digit, 1 plus 1 2. Again the next number will be sum of these two digit, 2 plus 1 is 3. Then again this two digit is 5. Again this two digit 8. Again this two digit is 13 maybe. Okay, in this order it will continuously increase. Okay, so how you will do this program? Let me try do this program. Enter a number, suppose we need to set the limit up to where it's going to print. Okay, so limit. Okay, enter the limit. Okay, so n. Okay, fine. So here is 15, n. Okay, so we will take two value here, suppose a comma b. So I am taking a as equals to 0 and b equals to 1. So because this two number is fixed, 0 and 1, so I'm taking a equals to 0 and b equals to 1. Now I'm taking the next number. Okay, what will be the next number? Initially I'm taking it 0. So first of all I'm going to printf Fibonacci sequence is, so first of all we are going to print these two value, %d and %d comma, then here I'm going to write here a comma b. Okay, so now in loop what we are going to do, this a and b value is still okay. Now I am going to print the third value, so that means it's next, right? Next equals to a plus b. Now I am going to print the value of next, printf %d comma, I am going to print here any next. Okay, now what I will do, so we will set here, that means a value is 0 and b value is 1, right? As per our declaration it will print here. Okay, now next value will also a plus b, that means 0 plus 1. Okay, so if the loop is continuously run, the value will remain unchanged until if I just swap the number a equals to b and b equals to next. Okay, so if I write this thing here, then what will do? So it will just swap the value, b value will be assigned to a and next value will be assigned to b. Fine. So here if I write this line here simply, so a equals to b comma b equals to next, this thing will interchange. Okay, before the loop will start again. Okay, then it will continuously run. Okay, so if I run the program, suppose I want to print the limit up to suppose 8. Okay, see here 0 1 1 2 3 5 8 13 21 34. How many terms are there? 1 2 3 4 5 6 7 8. 2 terms extra. Why? Okay, let me check the program again. Why 2 terms extra? Because we already declared these 2 terms. Okay, we already declared these 2 terms. So whatever user is defining, that time you need to do this thing. Okay, up to that terms is going to print. Okay, so how this program works again? So basically we are this printing these 2 line, right? A equals to 0 and b equals to 1. Okay, now here in next, when I going to sum the a plus b, then next will be 1, right? In first loop, then it's printing the value next will be 0 and 1 already print, 0 comma 1 already print, then it will print 1. Okay, as a next value. Okay, So again here what we are going to do, a equals to b, that means b value is 1 here, b value is 1, right? Okay, a equals to b and b equals to next. Okay, and next value is also 1 here. So okay, now a equals to 1 and b equals to 1. So again it will go here in this loop. Fine. So I equals to 1 as the condition is true. Next equals to a plus b. What is the value of a? 1 and 1. So in here it will print 2. A equals to 1, b equals to 1. So it will print 2 here. So if this is the output line, okay, it will print 2 here. Fine. So again a equals to b and b equals to next. What is the next value here? 2, right? Okay, so a value will be b, that means is 1, and b value will become 2. Okay, so in next time, next equals to a plus b. A value is 1, b value is 2, so it will be 1 plus 2 is 3. Same way a equals to b and b equals to, so a equals to 2 and b equals to 3, it will come 5. Again 3 and 5, it will comes 8. So like this way it will continue. Okay, up to n numbers of turns. Fine. This is Fibonacci sequence. Basically it will start from 0 and 1 and continuously it will print the next value as the sum of two previous value. Okay, Fibonacci sequence is over. Now this is prime number. So before printing the prime number, we need to understand what is a prime number. So prime number is a number which is divisible by 1 and itself only. So if I take n is a number, so if the number is divisible by 1 and n itself, then it's called a prime number. So that means if I take number n, it should not be divisible by any other number. Any other number except 1 and itself. So we need to check whether a number is divisible. It divisible by other number or not. If the number is divisible by other number, then it's not a prime number. So we can easily do this thing, right? We are going to, first of all, we are going to check whether the number is divisible by any other number or not. So prime number, that means 1 is not a prime number, not composite number. So we will start it from 2. Okay, the loop will start from 2. So if I do if, that means n. So I have taken n to check whether this number is prime or not. If n mod 2, n mod I. So here I is continuously changing from 2 to n minus 1, right? So here if I n mod I equals to 0. So that means we are going to check whether n is divisible by the number from 2 to n minus 1. If this condition gets satisfied, that means what? This is not a prime number. Fine. So we will write here not equals to 0. N mod I not equals to 0. Then you can say printf prime number. So semicolon. Let me just check whether this program is okay or not. 7 slash n id input, right? So here I will put 1 slash n, put here 7. See, prime number 1 2 3 4 5. So from 2 to 7, 2 to less than 7. So 5 time is printing prime number. So what we have to do, we have to just if I print this, okay, we have to set the condition in such a way the prime number will print only once. So we will take a variable, suppose t. Okay, so t equals to 0. If n mod I equals to 0, then t value will become 1. Okay, so I change here if n mod I equals to 0 here. So that means if this condition is true, then t value will become 1. So previously what is the t value here? 0, right? If this condition gets satisfied, suppose if I take a number 7, so from 2 3 4 5 6 7, so we are not 7, sorry, So from 2 to 6 we are going to check, we are going to divide 7 by this number from 2 to 6, right? So if the number is divisible by 2 or 3 or 4 or 5 or 6, then the t value will become 1. Fine, then t value will become 1. So if the if this one is not divisible by that means any one of this number, then the t value will remains 0. So that means here after the for loop I can set a condition here again. If t value is 0, that means what? That means printf the number %d is a prime number. Okay, so you can write here comma is, it should be n. Okay, then you'll write else part here, else just copy this line and print here the number is not a prime number. Simple. Okay, so let me just run the program. The number 7, the 7 number is a prime number. So if I take non-prime number again, 22, the number 22 is not a prime number. How we complete this one? We just check whether this number is, this n is divisible by any other number or not from 2 to n minus 1. So if the number is divisible by any number, then t value will become, what is the initial value is 0, t value will become 1. Then what we just compared, if t equals to 0, when the t value will remain 0, when the number n is not divisible by any other number. Okay, so that means the number is a prime number. So in our next program, what is saying, C program to find the sum of all prime numbers. Okay, C program to, okay, list of prime numbers up to a certain limit. That means we need to print all the prime numbers in a given range. Okay, we can okay, fine, m to n, you can say m to n, we are going to take, enter lower limit, suppose lower limit is m, and enter highest limit will be n. Okay, we have taken two numbers, so we are going to take, if I, sorry, we already take, okay, that thing we will change it later, I equals to m, I less than n equals to n, then I plus plus, then for I just change this j, then j, then you can write here j. Okay, so j equals to 2, j less than equals to I, j plus plus. That means whatever number it sent here, that up to that number we are going to change. Okay, so if I mod j equals to 0, then t will become 1. So okay, fine, if t equals to 0, then it's a, no, we'll print the number, right? So we need to check it here. If t equals to 0, we need to print it here. So this line is not required, so we'll print that all numbers, right? So if t equals to 0, printf, it will be I. Okay, fine. So if the number is not prime again, that means we need to set the t value 0 here, t equals to 0. So if I set the limit, suppose from 12 to 35, so 13, 17, 19, 20, let me just set a comma here. Okay, I just set a comma here. So if I write here prime numbers are, okay, you will write prime numbers are here. So we'll write here printf prime numbers are colon. So I'll just set a semicolon here. Okay, so fine, limit suppose from 18 to 42. Okay, 19, 23, 29, 31, 37 and 41. Okay, so let me just understand the program again. Okay, So how we completed this program? Okay, so here what I am going to take, so what we are doing here, we are just taking all the numbers from m to n. Fine. So if I set m is 16 and n is 35, from 16 to 35 continuously the number is running here. Okay, so here from here to here in this for loop we are sending the value of I here. So if the condition is satisfied, then the I value will come here. Okay, from j equals to 2 and j less than I. So if I value is 16 here, so I will come here, so I equals to 16 here. Fine. So what we are doing here, we are just checking if I 16 mod j. So what is the value of j here? So in this loop j value is continuously incrementing from 2, is checking from 2, so whether j is 16 is divisible by 2 or not, then checking with 3, checking by 4, checking by 6, up to 15 is going to check. Okay, so 2 3 4 up to 15 is one by one is checking the value, is checking whether I is divisible by j or not. Okay, so if it is divisible by j, then the t value will become 1. Okay, so it's a 16. So after is dividing this number by 2 is the 16 is divided by 2, right? So that means t value will become 1. So that means the loop is not valid here. So you can also use break here. So because the line is so if a number is divisible by any other number, then it will break here. Okay, break the loop here. Okay, this loop only this loop. Fine. So now again it will increment the number here m 17. So 17 will come here again. Okay, 17 will come here again. So we are going to check whether 17 is divisible by this number or not. Okay, so if the 17 is divisible by this number, that means the number is not prime again. Okay, so first of all we will check with 2, then 3, then 4, then 5, then 6, up to 16, because is showing j less than of I. Okay, so one by one we are going to check whether this number is this 17 is divisible by any other number or not. Fine. Then if the number is not divisible, as 17 is not divisible by any other number, so what we will do, the I value the t value will remain 0. Fine, t value will remain 0. Fine. So here if the t value is remain 0, that means the number will going to print. So under this for loop we are going to print the t value, because the number is continuously increasing here. Okay, from 16 to 35. So here in this way the list of all prime number we can print. Fine. So what is our next program? Okay, sum of all prime numbers. That means whatever you are giving, it will print the sum of all numbers. Simply you just do sum equals to sum plus is I, right? I simply and you will define sum here, sum equals to 0. That's all, and you will print the sum here. Printf, you can give a slash n here, otherwise it will print a single line. Okay, so 12 to 39. So these are the number 13, 17, 19, 23, 29, 37 and 31 and 37. So the sum of all the prime numbers is 714. I think the number is wrong. So okay. So I didn't put the bracket here. Another bracket should be here. So now it will become okay. Okay, what we are going to take is will be so from 16 to 39. Now it's okay, I think. Okay, the sum of all prime number is this. Fine. Okay, so today we complete 10 programs here. So rest of the programs we will complete in our next video.